So this one is regarding the numericals related to paper industry. So today we will be talking about some important numericals related with the chemical recovery plant of paper industry, especially for the students who are studying the conversion of green liquor to the white liquor. So this numerical is based on the concept of converting green liquor to white liquor in causticizing process. And for this one, we need certain ingredients here, especially the reactants are sodium carbonate and calcium hydroxide, and the product is sodium hydroxide and calcium carbonate. And for this reaction, we are having separate setup of equipments which are having the dissolving of smell that is coming from the chemical recovery furnace. So after burning the black liquor, we are getting the inorganic chemical in the molten stage. So it's called as a smelt, and a smelt is getting dissolved in the dissolving tank, and that will be making the green liquor. And green liquor is further reacted with another chemicals to make the white liquor, which can be reused in the industry. So let us see the problem here. So problem is given in the form of explain the steps for calculation of NaOH, sodium hydroxide, produced and requirement of calcium hydroxide in causticizing reaction for converting green liquor to white liquor in a chemical recovery plant in an integrated paper industry handling 100 tons of green liquor per day, which is having solid percentage of 12%. Assume any other data required. So if there are some more data required, you can assume the various process parameters as per the industrial value. As you already gone through the theory, so basically you can assume some parameters that are required. So different persons will be having the different parameters and values depending on the industry. Industry to industry, there are some variable of the input parameters. So certainly, if the input parameter is different, so it will be having the different output parameters. But the brief is same. Basically, we have to calculate the amount of NaOH produced and the requirement of the calcium hydroxide in the causticizing reaction. So you can see the solution here is in a stepwise manner. The first step is green liquor to white liquor. Basically, it's given in the form of the reaction. So sodium carbonate, which is coming in the green liquor as the main constituent. The sodium carbonate is reacting with calcium hydroxide and so giving you the 2Na with sodium hydroxide, 2 molecules, and calcium carbonate. Right, so basically the calcium carbonate is the byproduct, or you can say it's unwanted material. So further it's reacted to form the calcium oxide, and calcium oxide is again dissolved in water and it's forming the calcium hydroxide. So it's a closed loop cycle. So nothing will be going out of the industry, everything will be recycled here, and that will save the environment also. So let us focus on the reaction here. So for balancing this reaction and calculating the amount of NaOH and calcium hydroxide that's required to react the sodium carbonate, we have to balance the equation here and get the molecular weight of these chemicals. So molecular weight of the sodium carbonate is, you can see here, 23 into 2 given molecular weight for sodium, plus 12 for carbon, and oxygen having the 16. So O3 means 16 into 3. So we are adding all the 3, so we will be getting the sodium plus carbon plus oxygen. So total is 106 is the molecular weight of the sodium carbonate. It can be taken into gram or kg, or all the units should be same. We will be taking the SI unit, we will be considering these are given in the kgs basically. So molecular weight of the calcium hydroxide here, you can take the molecular weight of calcium hydroxide by adding the calcium molecular weight 40 plus 2 into molecular weight of oxygen 16 plus hydrogen 1. So it's 40 plus 34. So it will be giving you the 74. Molecular weight of the NaOH is sodium 23 plus oxygen 16 plus 1, so 40. Molecular weight of calcium carbonate, so 40 plus carbon 12, and for oxygen again is 16 into 3, so total it will be coming out 100. This is the second step. You have to calculate the molecular weight of the reactants as well as the products. Here are the two reactants, sodium carbonate and calcium hydroxide, and two products are there, sodium hydroxide and calcium carbonate. Now let us see the third step of the numerical. The quantity of the green liquor is already given. It's 100 tons per day is being produced in the industry. So 100 tons per day of green liquor, in which the main constituent will be the sodium carbonate as given here in the reaction. You can see here the sodium carbonate which is coming from the green liquor. It is being reacted with the calcium hydroxide. So first of all, we have to get the solid percentage in the green liquor. So 100 tons multiplied by, so numerical is already having the value. So given to you that 12% in the green liquor is solid, right? So you take the 12% of 100, so 100 into 12 upon 100 is giving the 12 tons of solid per day. That means out of total 100 tons of green liquor, the actual solid is only 12 tons, and the rest is basically we are having the water. Assuming that 80% of solid is sodium carbonate, that means out of the total solid, we are taking that 80% is sodium carbonate, and the rest will be some other type of the chemicals which are not participating in the reactions. We will leave them. So we will take the 80% of the solid, and 80% of the solid will be 12 ton is the solid, so 12 multiplied by 80 upon 100, so 9.6 tons per day. So you can see here now we have calculated the amount of the sodium carbonate theoretically, and by balancing the reaction, we've already seen that 106 kg of the sodium carbonate is reacting with 74 kg of the calcium hydroxide. Alright, so that's a given in the reaction. You can see here the sodium carbonate is reacting with the calcium hydroxide, and sodium carbonate is having the weight of 106. 106 kg will be reacting with 74 the calcium hydroxide. You can see here, and that's why we will be taking the fourth step here in the calculation that 106 kg of sodium carbonate is reacting with 74 kg of calcium hydroxide. So 9.6 tons of sodium carbonate will be reacting with 74 upon 106 multiplied by 9.6 tons of the calcium hydroxide. So calcium hydroxide, finally we are getting the amount near to 7.1 tons per day. Right? So how much quantity of the calcium hydroxide is required? It's a 7.14 tons, which will be reacting with the 9.6 tons of the sodium carbonate. Right, so this is the final answer. We have got the answer for here. That means how much quantity is required here. The another part was to get the quantity of the NaOH. NaOH produced. How much NaOH is produced here? You can see here the NaOH is 2 NaOH is produced. That means we are getting the 40 into 2. 80 kg of NaOH will be produced from 106 kg of the Na2CO3. Right, so 80 kg you can take it here. That means 106 kg of sodium carbonate is giving you how much? So giving the 80 kg of NaOH. NaOH, right? So again, you can see here mainly how much the quantity of sodium carbonate here. Sodium carbonate is 9.6. So 9.6 tons of sodium carbonate will result into how much quantity of NaOH? It will be 80 divided by 106 and take into bracket here and then multiply it by the 9.6. This much is the quantity of tons, and again all the calculations are per day, so it will be tons per day. Right, so you can calculate the amount here. It will be 80 upon 106 multiplied by 9.6 ton per day. You can get the quantity here. How much will be the amount? If you do the calculation, so here you can find out the amount that is given for the NaOH. In this way, we can find both the quantity of NaOH as well as the how much is the calcium hydroxide is required for reaction and how much is NaOH is produced. So let us see the another column. And another problem is given here. Explain the steps for calculation of removal of water amount in trace and dryer section different parts in an integrated paper mill handling the 500 tons of OD, that is the copier paper per day, which is dried from 22% solid to 50% solid in trace using the mechanical force and from 50% solid to 95% solid in dryer using steam. Steam required is 3.5 kg per day of water evaporated. Calculate the steam requirement on daily basis. Assume any other data is required. So again, this is based on the material balance. Again, you can do and solve it. At least you try it. Then we'll see in the next class. So we'll stop here only. And if you are having any doubt, you can send me on chat. First of all, go through it, then see it. Then if you are having any problem, you can ask on the WhatsApp also. Okay, bye.